Hello students, we now discuss scope of identifiers in functions in Python. What do we mean by scope? Scope is an area of effectiveness. See, variables are declared in different parts of a program. What do we mean by parts? See, function is a part of a program, and the main program in which statements of the main program are written, that area is called the main program, is a different part of a program. Okay, so for this discussion, realize that different functions and the main program act as different parts of a program. So identifiers or variables declared in different parts are known within their areas or parts only. Every function has its separate variables in memory. That is, for every function there is a separate area of memory in which its variables are kept, and the functions don't know about the names of each other's variables. Therefore, they can use the same variable names also. Now, as in this example, we have defined two functions by name f and g. Both are taking input argument by name variable a. Now, both of these variables a are different in memory. One variable by name a is for function f, and the other variable by name a is for function g. Similarly, main program is also having a variable by name a. Since it is having the same name, it is also kept separately in memory in the area of variables of main program. So there are actually three variables by name a in this program. Now, the variables which are declared in the main part of the program are known as global variables. Okay, so in this example, a and x are the global identifiers or global variables, and variables declared inside different functions are known as local variables for those functions. So in this example, variable a declared inside function f is local to that function, and variable a declared inside function g is local to that function. Now, global variables are allowed to be used inside the main program and the functions also, but inside the functions they can only be used, they cannot be changed. That is to say, you can print its value or use it in an expression or anything, but you cannot change its value. For example, in this program we are printing a and x in function f, and again a and x in function g. Now, for function f, the variable a has the value 60, because in the main program variable a has the value 50, and when function f is called in the main program, it is being passed the value 50. And what the function f is doing is that it is adding 10 to this value, so a now becomes 60, but this a is the variable of function f. It is not affecting the variable of variable a of the main program. So the statement print a comma x of function f prints values 60 and 25, and see here that x belongs to the main program, and it is allowed to be printed or used inside function f. Similarly, in function g, again a variable by name a exists. Now, when we call function g in the main program, it is again passed value 50. Okay, because although function f was called and it stored value 60 in its own variable a, but because the variable a of a main program was completely different from the a variable of a function f, so the variable a of main program still holds the value 50. So when function g is called, value 50 is passed in the as an argument. So now what function g does is it adds 20 to this value. So the a variable of function g becomes now 70, and again the print a comma x statement of this function prints 70 comma 25, because x is 25, it is not changed. Now finally, when the main program prints a and x, it prints values 50 and 25, because the variable a of main program is not changed anywhere, although it is passed to functions f and g in the in their argument variables, which are having the same name a, but and they are changing those variables inside their body, but still the because those variables are completely different from the a variable of main program, the main program's variable remains unaffected and it holds the value 50 only. Okay, so the print a comma x statement of the main program prints values 50 comma 50 and 25. Now we said that the different functions of a program don't know about the variables of each other. For example, see here in this example we have written two functions f and g. The function f is taking an input argument by name a, and function g is taking an input argument by name b. Now f and g don't know about b and a respectively, and therefore the print b statement in function f is not allowed, because function f does not know about variable b, because b is a local variable to function g and hence not known inside f. Similarly, the print a statement inside function g is not allowed, because variable a is local to function f and therefore it is not known inside the scope of function g. Okay, the next thing is that the statement inside the function f x is equal to 30 is not allowed, because global variables cannot be changed in normal functions. Okay, so therefore that statement x is equal to 30 in function f is not allowed, but there is a way to it. See, in function g, a statement is written global x. What this statement does is that it declares that x is a global variable. It is known, it is kind of declaring that I know about the global variable x, and therefore because of this statement it is allowed to change that global variable. Therefore the statement x is equal to 30 in function g is allowed. Okay, so whenever you have to change a global variable in a normal function, you must use the statement global followed by the name of the variable. Now in fact multiple variables may be declared global in a single statement by separating the variable names with commas. Now in the main function, after declaring the variables a with 50 and x is with 25, function f is called and function g is called. What function g does is it is changing the value of x to 30. So in the final line of the program, print a comma x of the main program, this prints values 50 and 30. See, x was declared to be 25 in main program, but since function g has changed the value of x to 30, therefore it prints 50 and 30. Thank you. Next, in the discussion of scopes in Python comes the notion of enclosing scopes. See, it is legal to define one function inside another. As in this example, we have written one function g inside another function f. Now, the variables of the enclosing function f are known in the enclosed function g, just like global variables are known inside functions. Now, variable x, which is defined inside f as having the value 5, is being printed inside function g, and it is creating no errors. It is completely valid, as the function g knows about the variables of its enclosing function f. Next comes the concept of built-in scope. We regularly use standard library functions like len, print, input, etc. The standard library of Python itself has its own scope which is called the built-in scope. This built-in scope is above the global scope of the program. Now we discuss the situation in which the same identifier is used in different scopes. Then which one is used? In the example program shown here, one function named g is being defined inside another function f, and a variable with name x is defined at three places. First, in the function g, it is given value x. In function f, another variable by name x is created with value 10, and in the global scope in the main program, yet another variable with the name x is created with value 20. Now look at the print x statement in the function g. Which value of x is printed here, 2, 10 or 20? The answer is that the nearest definition of a variable is used. Now the nearest definition of x in this case is the one in the function g itself, and that definition has the value 2. So print x statement prints the value 2. Neither 10 or 20 are printed. Okay. Similarly, when print y statement is executed, again y is searched for definition. Note that y is not defined in function g, but it is defined in function f, which is the enclosing function of g, and also in the main program, which is the global scope. Now the nearest scope in case of y for function g is that of enclosing function f, which is having value 3. So therefore it prints value 3, not 6, because global scope is not the nearest. The enclosing scope is the nearest. So whenever an identifier is searched, first of all local scope is searched if it has a definition. If it doesn't, then enclosing scope, if there is any enclosing scope, it is searched. And if the enclosing scope is also not having a definition, then global scope is searched. If global scope is also not having a definition, then the built-in scope is searched, as in the case of print and input statements, which are not defined in our programs. They are defined in the standard library. Now if the same identifier in different scope situation, since input function, print function, etc., we don't normally redefine in our programs, but if we do define them, for example, in this program we have created a variable by name input and put value 2 in it in the main program, then the built-in scopes definition of that identifier loses its meaning for our program. Now input identifier is no longer available for the function which is used to accept input from the user. Okay, so when the function f prints the value of input, it prints 2. So what is happening here is that input has become an ordinary variable for our program. It has lost its original meaning of built-in scope. So it is never advisable to redefine built-in scope identifiers in your programs.